graphing factor form of a quadratic. So this is a quadratic. The reason I know this, if I were to distribute, my highest variable would be to the power of 2. X times x would be x to the power of 2. So I know I have some quadratic function here. And the form I'm in is actually factored form, which makes it very simple. Makes it very simple for graphing. So the first thing we want to do is find out what the x-intercepts are. So an x-intercept essentially happens when y is equal to 0. We're crossing this x-axis here. So f at x represents y, so we're going to replace f at x with 0. Okay. So we have 0 is equal to x plus 2, x minus 6. Okay. In order to make 0, think of these as separate terms. This is a term and this is a term. And a term times a term to make 0 means one of them has to be 0. There's no other way to multiply and get a 0. So what we do is we set both of them equal to 0 and find out what the possibilities are for this. So you would get 0 is equal to x plus 2, and 0 is equal to x minus 6. Okay? In this case, you'll get x is equal to negative 2, and x is equal to 6. Oh. So those are your two x-intercepts to start. So I'm going to do a rough sketch on the side here. So that means we have one x-intercept at negative 2, and another one's at positive 6. Okay? When we look at the a value here, that's the coefficient in front, there's nothing there. So the assumption it is positive and 1. And if it's positive, that means our quadratic opens up like that. So we already know we have something in this fashion, but we've got to find a couple other key points. Really a key point will be where's the vertex of this. And the vertex will always be directly between these two x-intercepts. So now that I have them, the idea is called finding the axis of symmetry. So they usually call it the AOS. And what you do is you find one of the x-intercepts, you add it to the other x-intercept, and then you divide the two. So we have negative 2 plus 6 divided by 2. Negative 2 and 6 will give us 4 divided by 2 is the value of 2. So what that means is the x value of the vertex is at 2, and we just have to find out what the y value is. The x value of the vertex is same as the axis of symmetry, so it's probably roughly about there. It looks like it's in between. To find the y value, we can take our x here. Where is it? There you go. We take our x2, x is equal to, and plug it into the original equation, and then we'll find out what our y value is. So I'm going to rewrite that f at x. We're essentially finding f at 2 is what we're doing. So f at x had stated, I believe, x plus 2, x minus 6. So f at 2 would be 2 plus 2 and 2 minus 6. You end up at 4 times negative 4. Whoops, I wrote the answer before I wrote the actual value, negative 4. And 4 times negative 4 is negative 16. So the y value of the vertex is negative 16. So again, that's probably somewhere around here. That value is at 2 and negative 16. This here was at 6 and 0. This is at negative 2 and 0. And finally, the other major point that'd be very helpful is the y-intercept. A y-intercept would be whenever x is 0. So I can do the exact same thing, but this time I find f at 0, and it'll give me my y-intercept. So I have 0 plus 2, 0 minus 6. All I'm doing here is replacing the x value with 0, and that'll help me find the y-intercept. So I'm going to get 2 times negative 6, negative 12. So the y-intercept is at 0 and negative 12, and that makes sense because we know the parabola has to open upwards. So this value here is at 0 and negative 12. So we've essentially graphed, we've set up a rough estimate of what this parabola looks like, and we can check it out on, oh, am I on the right page? No, I don't have a version of it. Let's see if I can bring up Desmos. It was at x plus 2, I believe. X minus 6. Okay. So here's our parabola. One of the x-intercepts was negative 2. Another was 6. The vertex is 2, negative 16. And the y-intercept was 0, negative 12. And now you can use that information to essentially graph or transform or do whatever you need to with this question.